Large language models are shipping with expanding context windows, allowing them to ingest massive amounts of raw text. But pushing a system to its maximum capacity creates a severe bottleneck. Processing speed drops, and computing costs escalate with every single request. This creates a specific operational problem for autonomous agents. If you want an agent to follow a highly detailed internal API document or a complex deployment runbook, you have to feed those instructions into the model's continuous memory every single time it takes a turn. The standard industry workaround is to build an external retrieval augmented generation, or RAG, pipeline. Teams set up dedicated ingestion engines and vector databases just to retrieve relevant instructions. This adds heavy, brittle architectural weight to an otherwise lightweight system. The engine-naming tension here is clear. You need to give an autonomous agent durable, hyper-specific procedural memory. But you need to do it without relying on dense vector embeddings and without saturating the token limit on every prompt. News Research has engineered a native, file-based alternative to handle this exact problem within their open-source Hermes Agent. Giving an agent procedural memory is not a problem of building infinite context windows. It is a problem of rigorous file organization and strictly bounded token economics. The Hermes Agent skill system abandons the database entirely. Its procedural memory relies strictly on a standardized local file directory located right on the machine at c://skills/. To populate this directory, News introduced the /learn command. This command acts as the mechanism that takes unstructured raw data from the user and automatically converts it into a structured, reusable skill file. Developers can now capture complex, multi-step workflows as on-demand /commands. The agent handles the documentation, meaning you never have to handwrite a single line of instructional markdown. Let's trace exactly how a /learn command flows through the system. A developer initiates the pipeline by pointing the command at a local software development kit on their machine. Unlike standard AI systems, Hermes does not spin up a separate resource-intensive ingestion engine to parse those files. Instead, the agent simply delegates the sourcing task to the tools it already possesses. It utilizes its native search files and read file tools to explore the designated local directory and gather context. If the developer targets a URL for online documentation instead, the agent seamlessly pivots to using its web extract tool to pull down the text. Because the agent is doing its own sourcing, the collected data routes directly into the central processing node. No external database is ever queried. The entire process executes as a standard prompt turn. This means the sourcing pipeline works identically, whether in a local CLI, a messaging gateway, or a remote Docker backend. By relying strictly on native tools, the agent's ingestion capabilities scale exactly alongside its baseline execution capabilities, maintaining zero external dependencies. The agent translates collected data into a strict markdown file, SKILL.md. It applies a rigid formatting template. House standards hard-cap the skill description under 60 characters. Advanced conditional fields, like the platforms tag, restrict execution on incompatible operating systems or missing tools. Applying these rigid standards removes ambiguity. It prevents the model from hallucinating non-existent commands and ensures every generated skill integrates flawlessly with the agent's existing execution logic. Before this new procedural memory becomes active, the agent calls the skill manage tool. This is the final mechanism responsible for saving the newly authored document. Enterprise environments require oversight. An active security gate catches generated outputs and routes them to a pending staging folder for human review. There is an alternate path. If the write approval flag is set to false, the document bypasses the human check. It commits immediately to the primary directory and instantly becomes a callable /command. This bifurcated state management allows teams to calibrate their workflow. They can prioritize rapid, autonomous workflow capture or enforce strict enterprise security auditing. This raises an immediate scalability question. If a team generates hundreds of custom skills, how does the system prevent all those instructions from immediately flooding the agent's context window? The architectural solution is the progressive disclosure pattern, an open standard built to be fully compatible with agentskills.io. This pyramid illustrates the three-tiered loading system. Level 0 is permanent memory, a compact skill index capping continuous cost at 3,000 tokens. Level 1 injects the full SKILL.md only when deeper instructions are required. Level 2 fetches isolated reference files for hyper-specific technical lookups. Compare this targeted 3-level pull strategy against the massive baseline expense of stuffing every instruction into a continuous system prompt. Progressive disclosure keeps the token count low while effectively giving the agent infinite procedural memory with strictly bounded pay-as-you-go economics. Let's look at a high-value practical scenario. A developer spends 30 minutes manually walking the agent through a complex staging server deployment. Rather than repeating those instructions tomorrow, the developer targets the /learn command directly at their own recent conversation history. The agent reads the chat log and extracts only the successful procedural logic. It ignores the dead ends, the syntax errors, and the conversational filler. The procedure saves natively into the directory, instantly becoming a custom /deploy staging command. Exactly a week later, a totally different developer logs into a completely new session and invokes that same custom command. The agent flawlessly duplicates the previously recorded actions, autonomously executing the complex sequence of deployment operations with exact precision. This transforms a fleeting troubleshooting session into permanent executable institutional knowledge. The architecture we see here is highly deliberate. Hermes combines native file exploration, rigid markdown formatting, and tiered token management to author its own automated operating manuals. It proves efficient agentic memory doesn't always require the heavy architectural overhead of complex vector databases. By utilizing a rigorously structured local file directory and smart token economics, Hermes shows that the most reliable AI memory is built exactly like reliable software,